Welcome to this exciting tutorial where we'll build a simple, agentic AI application tailored for a supermarket's customer service department. Imagine automating responses to common inquiries like product availability, store hours, or return policies, all powered by AI to boost efficiency and customer satisfaction. Best of all, we'll stick to completely free, open-source tools from their community versions, ensuring no costs involved. By following my step-by-step instructions, you'll have everything installed and the app up and running in under an hour, even if you're new to this. Let us ask the question, do you have bread? The LLM understands a question, searches the product inventory, and answers with a greeting to the customer. Let us do a price check. What is the price of milk? Again, the LLM checks the customized product inventory and answers that it is $4. Let us check the application by asking about a product that is not sold in Angel's supermarket. Do you sell paper plates? The application checks the product list and answers, no.
Here's what we'll use. Ollama, a powerful open-source platform for running large language models locally on your machine. N8N, popular open-source automation tool that's perfect for building AI workflows and creating our intelligent agent. Postgres is a powerful, open-source, object-relational database system known for its reliability and robustness, used to store and manage data for web and enterprise applications. Whether you're a developer, business owner, or AI enthusiast, this project will show you how to harness these tools for real-world impact. Let's dive in and get started. Install community version of N8N in a local machine as a Docker container.
Let us install the free version of N8N on your local machine. There are many ways to install N8N. We're going to run N8N from a Docker container. You have to install Docker Desktop first if you don't already have it. Check the Docker website for instructions. You can also check the other video, Integration of LLM with MCP Server, in this channel for step-by-step instructions. Then, we will create a Docker Compose file, which has instructions for creating a Docker container for N8N. Run the command in the command window and generate the Docker container. Then, we will access N8N and verify it. We will also see how to stop and restart N8N. If you have successfully installed Docker Desktop and it is running, it will look like this when you open it. Currently, no containers are running. If you have any running containers, they will appear here. To set up an N8N container, you need to create a Docker Compose YAML file. This is a text file that requires proper indentation to define the configuration for running the N8N container. First, pull the official N8N Docker image from the Docker Hub repository. Next, define key environment variables with appropriate values in the Docker Compose file. You can customize the admin username and password for N8N. By default, N8N runs on port 5678, but you can configure this as needed. A sample Docker Compose file is provided in the video description, so you don't need to write it from scratch. To create an N8N Docker container, use a Docker Compose file. Open a terminal and run the following command. Docker Compose upd. Ensure the file is named dockercompose.yaml and is located in the current directory. Within a few seconds, you'll see a confirmation message indicating that the N8N container has been created and is running. Open Docker Desktop. If the N8N container is running, it will be visible in the Docker Desktop. In Command Window, use the command Docker Compose down to shut down N8N and Docker Compose up D to restart. Open http://localhost 5678 in your browser. When running N8N as a Docker image on a local machine, the initial owner user account requires an email address during setup. Now N8N is ready for use. Let us install Ollama server. Ollama is one of the popular open-source LLM. Go to ollama.com, click on the download and select OS. Run the download file and install. http://localhost 11434/ give the message. Ollama is running. Go to terminal, type Ollama. The commands are displayed. Ollama serve command also will start the Ollama server. Some of the frequently used commands are run, stop, list, rm, etc. Let us install few LLM. Go to Ollama website and click on models. Various models are listed here with tier size, number of parameter, etc. Select Llama 3.2 and copy the instruction to install. Model will be downloaded in the local machine. It will take few minutes depending on your machine and the size of the model. When it is done, you can type some prompts and check. Let us ask, what is the capital of USA? And the model gives the answer, which proves the model is installed and working.
Let us create the workflow for the supermarket customer support application in N8N. You can download the workflow in YAML format and load it in your local machine. Follow the step-by-step instructions.
Go to N8N and click on the Create Workflow menu. The N8N canvas is a visual editing interface where we create our automation workflows. Click on the plus sign to start the workflow and search for the chat node. Select the chat trigger node. There are parameters and settings, but we don't need to provide any values. Click on Back to Canvas to return. When chat message received is the default name of this node, you can change it if desired. This is the trigger node, which allows us to capture chat input for our application. You can hide or show the chat. Move the chat node to the left to make space for additional nodes. Let's save this workflow as Customer V1 for version 1. Click on the plus sign next to the chat node and search for AI nodes. Select the AI agent node. The prompt from the chat node is the input for this AI agent. No need to set any values for now. Click on Back to Canvas. We will connect the Ollama LLM as a chat model in the next step. Make sure you have installed Ollama and the Ollama 3.2 model is running. You can verify this by using the following URL in your browser: http://localhost 11434/API/tags, and check the pretty printed output. You should see an entry for Ollama 3.2. I am running multiple models, which is why there are multiple entries. Click on the plus sign below the chat model in the agent node. Search Ollama and select the Ollama chat model. There are N8N nodes for other models. We will see why we want to use Ollama at the end. Select the model, Ollama 3.2, latest. Click on New Credentials and create them. Since I have already created credentials, I will show them in edit mode. Enter the following URL as the base URL: http://host.docker.internal 11434/. That is all you need to connect to Ollama. Click on the Retry button to test the connection. If you are running Ollama on your local machine, you don't need a username, password, API key, or similar credentials. If you use other models from Google, DeepSeek, Anthropic, OpenAI, or similar providers, you will need to use API keys for authentication. Their free versions typically don't support API keys, so you would need a subscription version. I suggest using Ollama, which is free, if you are using it solely for learning purposes. We have a chat node to enter input from the user and an AI agent node to reply to the chat. Let us do a simple test to check the workflow with some hard-coded sample data. Double-click on the AI agent node and select System Message from the Add Option drop-down list. You can expand the window by dragging the edge. Replace the default system message with the custom message for our application. I will give this message in the video description. You don't have to write it down. We are giving instructions to the AI agent on how it should reply to the user. We are saying, you are a helpful assistant for customer service. Reply to product inquiries based on the inventory given below. We give step-by-step instructions. If the product is available, say yes, otherwise no. If the price is asked, always reply for 1 unit. Answer only the asked questions. Do not ask additional questions in the response. Then we give sample data for the inventory. We have milk, which is $4, and bread, which is $2. If you have noticed, we are giving generic instructions to the AI model, and they are not answers to specific questions. Now, let us test the model we have customized. Open the chat, click the 3 dots, and select Pop out the panel for better visibility. You can also move and expand the panel. Let us ask the question, do you have milk? It answers correctly. Yes. Next question. What is the price of milk? It answers correctly, $4. Do you have bread? The answer is yes. Now let us ask, what is the price? Without mentioning that we are asking about bread. It answers, the price of 1 unit of bread is $2. The model remembers that we are asking the price of bread from the previous question. Now, let us ask a question about a product which is not available. Do you have sugar? It answers correctly as no, since we did not add sugar as a sample product in the system message.
Agentic AI application. Agentic AI application refers to a software system that uses one or more AI agents to autonomously pursue complex, multi-step goals. AI agents. AI agent is a software system that can perform tasks autonomously to achieve goals. N8N agent node. The AI agent node in N8N is a core component of its advanced AI toolkit built on LangChain. Key components. LLM model, the brain that processes input, reasons, and decides actions. Tools, external functions / APIs the agent calls to act. Example: search, email, database queries. System message, configurable instructions guiding the agent's behavior. Building a real-world customer support AI with N8N and Postgres. In the current workflow, we've hard-coded just 2 products, milk and bread. This means the AI can only answer questions about these items, and the inventory stays static no matter how many sales happen or new stock arrives. But in a real supermarket, inventory changes constantly. Customers buy products. Vendors deliver new stock. Stock levels update in real time. Let's build a smarter, more realistic customer support application. We'll replace hard-coded data with a dynamic database. This database will store all products and their current inventory. Now, every app in the customer support system, like sales and warehouse, will use the same live database tables. That means the AI agent will always answer based on real-time stock. No outdated info, no manual updates. Let's upgrade from a demo to a production-ready customer support bot powered by live data.
Let us install a PostgreSQL database to store our product list. It is free. First, prepare a Docker file. The file should be named Docker file in the current folder. Use the official PostgreSQL Docker image. Let us name our database customer with username Angel and password MyAngel. You can choose any name for the database, username, and password, but remember to use the same names when authenticating and configuring in other tools. We are using the default port number 5432. You can use a different port number if another application is already running on 5432. Then, use the docker run command to create and start the container. You can run the commands one by one in the same order in your terminal, or store them in a file named run.sh and execute it from the terminal. We will name the container as my Postgres container. We will also validate that the PostgreSQL database is running in the Docker container using this command. All these instructions will be available in the video description, so you don't need to write them down. Let us store this command in a file named as validate.sh. Go to the folder containing your files, Docker file, run.sh, and validate.sh. From the command line, run the following command: /run.sh. I am not running it now, since the container has already been created. Then run /validate.sh. You should see the message, PostgreSQL container is healthy and ready. If not, investigate what was the issue. Now we need a client tool to access the PostgreSQL database and add the data for our product list. There are many tools available. We are going to install pgadmin, which is one of the powerful tools to manage the database. This will also run as a Docker container. Run this command from the command window. Give a valid email address as the username and a password. Then go to the browser and use the URL http://localhost 8080. Let us connect the admin tool to the database. Right-click on servers, then register, then server. Give a name for the server. Let us call it N8N. Click on the connection tab. Give the host name as host, docker.internal since the database is running as a container, port number as 5432. Database, username, and password which you had given in the Docker file. Now we have the connection to the database. Let us create the table called products and load some sample data. Select the customer database and click on the query tool. We are going to use these SQL statements to create the table and load the data. Make sure to commit after each statement. Paste the SQL and execute the query. I have already created the table and loaded the data. First, copy and paste the Create Table SQL statement. Select the entire statement and click on the Execute Script button. Then commit the executed code so that the table will be saved in the database. Then copy and paste the sample data. Select and execute the script. Make sure to commit. The SQL statements are available in the video description. Let us verify the data loaded in the table. Run the following SQL query to check the data. Select asterisk from products. If you can see the data, you are good. Let us check the containers. Go to Docker Desktop and make sure the PostgreSQL database is running on port 5432, that the pgadmin tool is running on port 8080.n8n is running on port 5678. Clicking any of these port numbers should open the corresponding tool in the browser. This is the first version of the workflow in which we have hard-coded the products in the AI agent system message. Only milk and bread are the available products in the supermarket. Let us do a quick test. Do you sell coffee? The answer is no. Do you have milk? The answer is yes. This workflow is giving correct answers. Let us copy this workflow and create a new version of the workflow so that we don't close the current working workflow. Click on the personal icon on the left. Click on the 3 vertical dots for the customer _ V1 workflow and duplicate. Let us call this customer _ V2 workflow. Now we are going to remove the hard-coded product list and add the Postgres database as a tool to the AI agent so that we will have a dynamic product list. Make sure we are changing the customer V2 workflow. There is no change in the chat message node. There is no change in the Ollama model connected to the AI agent. We are still using the same authentication for the Ollama 3.2 model. Click on the plus sign below the tool in the AI agent node. We are adding the Postgres database as a tool to the AI agent. Search for Postgres and add the Postgres tool node. Let us create the credentials to connect with the database. I have already connected. Give the host as host docker.internal. Give the same database name, user, and password you gave in the Docker file. Test the connection and make sure it is successful. Change the tool description to set manually. Give the following sentence as description. Execute a select query on the products table. Input must be JSON. Query. Select. Only select allowed. Change the operation to select from the drop-down list. Enter the value public for schema and products for table. Leave other values as default. Click on Execute step in the top right. You should see the product list in the output. All right. Now the AI agent is successfully connected with the database. Let us rename this Postgres node as run_SQL. Make sure that you are not clicking on the plus sign on the right side of the AI node. We are not adding Postgres as another node in the workflow. We're going to change the system message of the AI agent, which defines the core behavior and decision-making logic of the AI model. We give a table name and the columns in the table. We are telling what the tool used is, the set of rules, and a few examples, explaining to the model how to answer. We are not giving answers to every possible question we give, only a few samples. We are giving how the user call will be, how to prepare the input for our tool, run_SQL, which is the Postgres database, and how the final answer should look. This message is available in the video description. Let us add memory to the AI agent so that it will remember the previous conversations. Click on the plus sign below the memory in the AI agent and select Simple Memory. Let us use the default, which means that the model remembers 5 previous conversations. We missed one configuration for the AI agent. Change the source for he prompt as defin below and enter the value $JSON.chat input. Now let us test the workflow. What is the price of laptop? The application gives correct answer. If you have noticed, we did not give the price of laptop in the system message. The price is pulled from the database. Do you have any shoes? This is a generic question, not about any specific product. But the application gives correct answer. Do you sell sugar? We don't have this product in the inventory, and we did not have this question in the system message. But the application gives correct answer. You may not get correct answers for all the questions. If you get wrong answer, update the system message so that the model understands the context better and provides more accurate responses in the future. You can also change the data in the database and test the workflow. We missed one configuration for the AI agent. Change the source for he prompt as defin below and enter the value $JSON.chat input.
Now let us test the workflow. What is the price of laptop? The application gives correct answer. If you have noticed, we did not give the price of laptop in the system message. The price is pulled from the database.
Do you have lamp? The model did not give the answer. It has created the query, but did not execute. In the next section, we see few tips to fix this error. Do you sell shoes? I did not get the answer. The model just replied with a SQL statement. Currently, we are using the Ollama 3.2 model. Installing Llama 3.1:8b and changing an Ollama node fixed the issue. Since you are already running Ollama, do the following commands from command window. Ollama pull Llama 3.1:8b. Ollama run Llama 3.1:8b. Then change the model in your Ollama node. Now we get the correct answer. Do you sell fitness items? This is a generic question with item category, but not the item name. We don't have any sample question in the system message. The model correctly answers yes. What are the electronics items you sell? We ask a query based on the category, not on the item. Even though this type of sample question was not given in the system message, the model knows how to query the database and gives the correct answer with name of the electronics items.
Do you sell mobile phones? In the current inventory in the database, we don't have mobile phone, but somehow the model gives the wrong answer that we sell mobile phone. We have to change some configurations or improve the system message. There are a few tips we will see in the next section. For the question, do you have water bottle? In addition to saying yes, the model reply with the current quantity in the inventory. Currently, we have 300 water bottles. Let us update the quantity of water bottle in the products table as 0. Go to the PG admin tool and run the following SQL and commit. Update products. Set quantity equals 0, where name equals water bottle. Run the select statement and confirm that the quantity is 0. Now, let us ask the same question to the model. It says, yes, we have water bottles in stock. We currently have 0 available. It found the quantity is 0, but the answer is wrong. We have to tune the system message to give the correct answer. Now we have an idea of testing and improving the solution. Tips for improvements. Change the model. As demonstrated earlier, switch to a model that is better suited for the specific task you're performing. One that is larger, more advanced, and up-to-date. For instance, if you're using Ollama locally, consider upgrading to paid API-based models like Grok, GPT-4o, or Claude 3.5 if you have a subscription. These often provide superior performance, especially for complex reasoning, code generation, or natural language processing tasks. Tune the system message. The AI model will behave according to the instructions you provide in the system message. To optimize it, include clear, step-by-step guidance, relevant examples, and any necessary context. Additionally, always review the system message for syntax errors, especially if it includes commands or code snippets. Set temperature. For more deterministic and reliable outputs, reduce the model's temperature setting to near 0, e.g., 0.1 or 0.0. This minimizes randomness and creativity, leading to more consistent and accurate results, which is ideal for tasks like data processing or error checking. N8N subscription. If you're building more advanced workflows, consider upgrading to a paid N8N plan to avoid limitations and bugs commonly encountered in the free community edition. The starter plan begins at around $20 per month, offering features like unlimited executions, priority support, and advanced integrations. Let us summarize what we have done in this video.
We can also export the N8N workflow, which will be a JSON file. You can use it as a backup, share it with others, or import it into another system. Click on the 3 dots and then select Download. You can open a blank canvas and import from the file that I will provide the link to this JSON file in the description. It will be useful for you to see the values in the workflow. This is the chat node. This is the AI agent with all the parameters. This is our Ollama LLM, Postgres database, simple memory, etc.
We just created a fully working agentic AI application without writing a single line of code, using only free tools. No code, no cost, and I'm just learning too. We covered what is agentic AI, how it actually works, and the core pieces you need. The cool part, you can do this too for free. Download ready-made workflow JSON from the link in the description, import into your local N8N, and watch your AI agent come to life. I'm not an AI expert, just learning and sharing. If this helped you, please give it a thumbs up and subscribe. I'll keep making simple, free AI tutorials. What's next? The Community Edition has limitations. All the features of N8N are not working in the Community Edition. The subscribed version is $20 per month. If you're serious about developing N8N workflows, you can go for the subscribed version. Explore other nodes using the Community Edition. Stay tuned for additional videos.
If you found this video helpful, smash that like button, subscribe for more automation tips, and hit the bell so you never miss an update. Thanks for watching, and I'll catch you in the next one. Bye. Bye.